So the reason I wanted to do this is common to everybody in the room. And in some cases, multiple extractions, right? You got Malic 3, if you're in the West, you're doing Olson, you're doing nitrate, etc. My point is, the second biggest consumable after DI water in your labs, part of your lab, filter paper, right? Everything we do in soils, with the exception of leco-analyze instruments, is running through filter paper. So this is the reason I want to do it. It's common to everybody, and we take it for granted, right? So, Gary, it's not advancing. Yep. I'm gonna go up here and hit. Yeah, I tried the arrow key and it didn't work either. Huh. There we go. I guess you're gonna be my pen pusher. So it's nice to have somebody who pushes the slides, keeps you on time, right? Anyway, so really want to take this point and talk about, the Illinois Soil Testing Association. You guys, many of you in the room are kind of new to it because I've been here over 10 years. So my point is this organization has really changed over the decades. Oh, there you go.
It works.
It works now. Yeah, that's the one I was putting. Okay. So my point is this organization is really pulled through in terms of bringing new people into it and talking about subjects like we just spent the last hour on. So without further ado, if we take an extraction method like Malic 3, and I like to break it down into these stick figure charts because it kind of breaks out the process where you got the extraction going on as its own component. You've got the soil, you got the scoop, you got the extractant, you got the shaker, you got the filter, and then you've got an aliquot that goes off the ICP for analysis. Separate from that, down there in the lower bar is that soil sample that has to get dried, ground, and pulverized. But my point is I break that out that way because everything that we do for these typical extractions all has to go through that green filter paper step in your laboratory. It's fundamental to all these different types of soil extractions. So what is filter paper? It's a semi-permeable paper barrier that allows the liquid to go through and allows it to go through that filter paper and still retain soil material so that they're completely separate. So we're basically separating a solid phase from a liquid phase, okay? Its important parameters in the lab is it has to have strength. You don't want it to fall apart when it gets wet. It has to be porous enough to let the liquid go through, but retain the particles of soils, sand, silt, and clay, and organic matter that are too large to go through the paper. It has to have a reasonable flow rate, right? You don't want to have a paper that takes 4 or 5 hours to flow through. I mean, most labs, I think, in this room operate with a Malic 3 filtering time of at least 15 to 20 minutes, right? I mean, I know people who let it set on that thing for 2 hours because they're too busy, but anyway, and it has to be efficient. Okay, so the type of paper used in the laboratories differs according to the procedure that we're looking at and the chemicals we have, right? We don't want to use a paper that's going to fall apart in a particular solid phase, for example. Okay, so typical filter paper materials are made for, in our business, is made up from a cotton fiber or what they call a cotton lint cellulose. This is basically cotton fibers that are clean, and then they come up with a certain size fraction and they press them into shape. Typically, they're 10 centimeters in size. If you're doing saturated case, you're probably going to use a 15 or a 20 centimeter size filter paper, depending on what kind of Buckner filter you have. I know not many people in the room operate and do saturated case. Sometimes they treat filter papers with a particular impregnation material so that they'll attract different materials. I mean, it's all filter papers have different specialities. So there's your photographic micron of looking at a cross section for filter paper material. So there's basically 2 types of filter papers that we talk about in analytical chemistry. One is the qualitative filter paper, and they come in different grades. Grade 1, which has a larger pore size, the materials go through. There's grade 2, which is finer. There's grade 3, grade 4, and you get into all kinds of specialty filter papers. You can have ones that are dealing with aqueous type solutions. You can have ones with organics mixed in with them. They're all different kinds out there. Pretty much our soil testing industry is focused on materials that are either in the grade 1, grade 2. If you're some type of researchers, you may be down there in a very special grade that has very low percolation rates to it. Then there's quantitative filter, where you're going to collect some material on the filter paper, and it's got to be perfectly clean, and you're going to do a quantitative analysis on that. Now, when I first got into chemistry, we did this for collecting barium sulfate crystals. Okay, that's a quantitative process. You collect the crystals on the filter paper, and then you measure the weight. So there's all kinds of different applications of filter paper for chromatography. There's glass filters, there's PTFE. Each have a specific chemistry process that they're designed to focus around. Cellulose papers, this is just off the Wattman's website. You got your grades there, and you have your particle retentions, and then they have a little bit of description information there. Where does Wattman say 1, 2, 3, 4, then there's 40 and there's 42. And if you'll notice, as you go down that column, 1, 2, 3, and 4, the basic differences there is the particle size that they're going to allow through that filter. And they're down at 40 and 42. You know, there's a big difference between 40 and 42 in terms of the type of particle it's going to allow through that filter. Now, there's a filter conversion chart, which is really helpful if you want to compare different filter paper properties between, say, Wattman and Alstrom and a couple of the other manufacturers there. It's really a very helpful site if you want to start saying, well, is this the same paper I'm using in my laboratory today? Okay. And Bantech, which is probably number 3 or number 4 in terms of filter paper suppliers, has a good thing because they use a different grading system there. And then they give you, I like this, they give you the weight, the thickness, the flow time, and then the absorption speed. It's really helpful because you know when you get into different soils and heavy clays, they're going to obviously filter much, much slower than, say, a loamy sand. You know, the thing I find most distressing in this is you got a filter paper manufacturer, and he tells you one thing about the grades and the permeability. And then you come over to another manufacturer's and like all the rules have changed. They've gone from miles per hour to kilometers an hour. It's kind of hard to make those conversions back and forth. When I look at filter paper, I look at primarily 3 things when I used to run the laboratory at Davis. First of all, minimal contamination. I don't want to have, if I'm testing for sodium, I don't want to have sodium in my filter paper. I don't want to have nitrate if I'm testing for nitrate. Speed of filtration. The finer the pores, the slower the filtration rate. I can't tell you how many labs I've been in. Wattman 1 world rules. Okay, it's just fast through. They want to get that speed through the laboratory. I can tell you when I used to do research, I used Wattman 42 because we wanted to keep the clays out of the suspension. The next thing is that filtration time, and it's minutes, not hours. And then lastly, filter retention. I want that filter paper to retain the fine particles. I don't want them mixing into my solution. Okay. So first thing, I'm going to talk about contaminants. And Christian Hicks here runs the North Carolina Department of Ag plant and wastewater lab. And this is a state program lab. It's not a university lab. And she's been director there, I think, since 2014. And she's done an evaluation of 7 different types of filter papers. So she looked at Alstrom, Wattman, and Sartorius, and a TSP supplier. And what she wanted to do was see how many contaminants were in these filter papers. And so they did 2 types of tests. They did a DI water test where they just rinsed the filter paper with DI water, and they see what kind of analytes they were picking up in that solution. And number 2 is she used them as blank digest where the nitric acid digestion is as if they were a plant digest. And what kind of materials these papers were providing in that nitrate acid blanks. Okay. So a lot of information on this slide. You'll see all the filter paper grades that the Wattman's, Alstrom, Sartorius, and what the TSP supplier do. A lot of information in there. The bottom line, these represented the type of filter papers they were trying to decide if they were used in the laboratory or different processes in the lab. And I make note here, I mean, wild changes in grades, wild differences in pore size, differences in how fast those pore size allow speed to go through. I had never heard of the Hertzberg filtration speed before. But I guess that's the thing. Somebody standardized that process. You'll see that Wattman 540 was 200 seconds. You'll see the Wattman 41, 54 seconds. That must be quite a difference in that type of paper. And center down there. You can see that there's wide things. And it's nice to look at this information, but how does these papers held up in terms of holding up in terms of the lab? So these were the results of her contaminant test. There's your different papers, your DI water rinse, and your nitric acid rinse. That first paper there, 1/3 of a part per million sodium. That was the only thing they found in the DI water. If you go down that list of the DI water tests, you'll see all these papers had some contaminants in them. Sartorius grade there was probably one of the lower ones, 1/2 part per million calcium, about 1/2 part million sodium. A little surprising there that Ulstrom grade 392, almost 1.4 parts per million ammonium. Obviously, you wouldn't want to use that paper if you're doing any kind of ammonium and nitrate analysis. So good information to have if you're going to assess a procedure in your laboratory. You have to take into consideration, is the filter paper I plan to use, maybe I have on my stock shelf, is that going to work or not? In terms of nitric acid, surprisingly to me, she had several papers there and had almost nothing in it. It was below her method detection. Also surprising to me that that first paper and that Sartorius grade 1289, 4 part per million calcium. That could really screw up a low calcium test if you were analyzing plant tissue, like corn stalks or wheat residue. That would have a lot of calcium. Okay. So in summary from her work on 2 of 7 cylinders with DI water had significant contamination of nitrate and ammonium in their materials. Calcium and sodium contaminants were in the nitric acid digest above their MDL for those procedures. And I really stress this business of high calcium exceeding 1 part per million. You know, if your blanks are running that high, you know, you've got to take that into consideration. So she's done all this work. They made some choices after doing this. This was recent work that was done, I think, in 2023 and 2024. And so they made these, used these decisions, which filter papers do these. Now, there's one round robin of testing filter paper to take care of things, because batch size to batch size, lot purchase to lot purchase, change things. Think about this. This is something you need to be aware of. Things change in the production systems for these filter papers. I can tell you a lab in California, they bought 250,000 circles of Wattman 3 to use in their laboratory for all their extractions in their soil business. And when they put that new batch in the new supplier online, blanks started going up in their face for sodium and nitrate. And they went back to the supplier. He sent them another couple boxes for evaluation after they bought 4 million circles. And they were just as bad, because they changed manufacturing sites from, I think it was, they changed it from China to Southeast Asia. They had a huge bonfire to burn up all that filter paper because they found it was, it wasn't worth their time to clean it up. Also in a lab in Canada, they got a batch filter paper in. It was contaminated with nitrate. They run that filter paper with nitrate. They end up spending, what did they die? I think they said 160 hours cleaning up filter papers, pre-leaching them with acetic acid to purge them of nitrate, and then re-drying them so we use them in the lab. That would be a fun project to get involved in. So the second part of my presentation, I talked about filtrations. And so I went out and I asked North Carolina Department of Ag, University of Florida, Oregon, Oklahoma State University Swaffle Lab, I love the name, Soil, Water, and Forage Lab. Okay. And a commercial soil testing lab. But I asked them, send me some filter papers. And I brought them to Colorado, and we did a filtration study. And we picked the soil out of the AOP archive. And the reason I picked this particular soil, it's a sandy loam texture, it's 30% clay. And I have gotten multiple feedback from labs that got this sample earlier this year. It was 2501. And they said, Bob, that's a really slow filtering sample in the lab. And I knew why. It's full of iron oxide, it's full of 1-to-1 soil clays. And so we evaluated this. We mixed it up with Malic 3, used a 2-gram scoop, 20 mils of extractant. 50 mil centrifuge tubes. We shook that for 5 minutes like everybody else does. And it was selected because it's a fine kaolinitic ultrasol. It's dominant in kaolinitic clay. It's got a lot of clay. It's very fine. It also has a lot of iron oxide, which still plug up this. You see, thinking of filter papers. And as I said in my note, cycle 56, there was a lot of labs that complained about it. So this is what the tests look like. Here's your 4 filter papers side by side. You'll notice that 2 are conical, basically treated to form a conical sphere. The other 2 are just folded. So I call those pleated folded papers, okay? And, standard process, reciprocating shaker for 5 minutes. From the time we pulled it off the shaker, the time they went to filter papers, just had a 1 minute hold time. We didn't want that material to settle out, okay? And we collected 50 mil centrifuge tubes, and we measured the rate of the filter through these centrifuge tubes here. We measured that over a 20-minute period. And this is kind of what it looked like. You can see that it's got a lot of that iron oxide in it, which makes it really slow down. But our purpose was to see what's the speed on these particular 4 different filter papers. So here you go. Here's the test results. We have the time, filter paper 1, 2, 3, and 4. I'm not going to tell you whose paper this is. I'm not going to tell you where they came from, what university, because I do not want to get in trouble. Right? If I start telling you that Alstrom was the worst one up there, there's a consequence. So, filtration volume there, we measured that again for 20 minutes. You know, it's nice to look at these numbers. The bottom at 20 minutes, they're almost all the same volume. You put in 20 mils, you get about 16 mils back, no matter what type of filter paper you do. But you'll notice FP1 and 2, they're a little slower than FP3 and 4. Those conical ones were a little slower to get started, but in the end, they all finish at the same time. If I look at this as a graph, and I pulled the 2 conical filters together versus the folded filters, you can see those folded filters are much faster initially, but they all flatten out at the same time. Those conical papers, even though they start off slow, they end up at the same point after about 15 minutes. So the bottom line is an ugly soil like this is about 15 minutes to filter. We did look at what it was if you just poured maleic 3 through. You get about 15 mils of maleic 3 straight through a filter paper in about 5 minutes. So the soil significantly slowed down that process. Okay. So the last thing I'm going to talk about is particle retention. How good does these hold the clays above the filter? That's our ultimate goal, right? We don't want the clays and the fine iron oxide getting into the solution. So the way I decided to evaluate it, I did that same study from the time study, and we used a turbidity meter or a nymphometer, and we basically took those extracts and we poured them in the nymphometer after we calibrated it, and we took a look at how much turbidity was in that solution. Now, visibly to the eye, those conical filter papers, we couldn't see it. But in the 2 plated filter papers, there was one, FP3, we've seen a lot of suspension in there. I mean, you could shake that tube and you can see the stuff form a cloud inside. And so here's your nymphometer results. And these are NTUs, okay? That's just the way water quality people speak. But you'll see that FP4, FP1 were the lowest, FP2 was still pretty low, FP3 is considerably higher. But what did that mean? If you use a rough estimate of particles in suspension against the NTU value, it's about 3 parts per million per FTU unit. That FP3 had significant amount of material in suspension. Okay, the other 2 were pristine. And by the way, the blank was 0.004. So bottom line, even there, the FP1 had a little tiny bit of material end up in that suspension. So that was the results of the retention. Taking a look at that FP3 one with the highest amount of turbidity, after we poured it into filter paper, we still had that droplet at the bottom that you can see is very cloudy. Okay, that was material that in the transfer process, it was still at the bottom there. It had a little settling to it. That was clearly evident that that FP3 paper had a problem. And I can tell you that from repeated conversations in labs, if you're using a conical filter, I don't care what grade it is, they seem to hold up better. Fewer filtration failures. I don't know how many of you have experienced filtration failures, but I got to tell you, they're a pain, right? Because now you got to go back and start the process all over. So, bottom line is that soil, which is collected in Jackson County, Georgia, has a lot of iron oxide, and that's why it gives it that yellowish orange color. So, contaminants, the summary is, you know, I got to tell you this, when you buy filter paper, you should be running them through DI water and looking for these particular anions and cations, because those things at the low detection limit are going to cause you an issue in your blanks. On night, I don't know, I don't think very many in this room filter for your plant digest, do you? Show of hands, how many people filter plant digest for ICP? Okay, a few. It depends, right? Yeah. When I ran the lab, I let them sit on the bench after they come out of the microwave, and then I did pour them into the ICP tube and call it good. But in case of Christian, she's filtering all this, and I know a few people raise their hands in here about filtering this. So that's something you need to be aware of. If you're going to use filter paper in the process of filtering for ICP off of plant digest, routinely checking those papers every time you buy a new lot. One folded filter paper source had significant turbidity issues. In other words, it was leaking clays and fine particles into the solution. And I got to tell you, when I look at digest coming through a percolation on a malic free or anything like that, man, if I see any kind of turbidity, I have to start standing back and saying, it probably needs to be refilled, because any of that turbidity, I'm going to show up in the plasma and bias the results on. The further research, this is where Bob ran out of time. I wanted to take all those extracts and send them off to a lab and ask for the malic-free analysis after they came through the filter. That would have been the proof in the pudding, right? Does the turbidity counteract or look like what we get out of a soil extract? Does it affect the result? Don't know. I think it does, but don't know. So that was something I ran out of time to get this done. So take home, when you purchase filter paper, you need to assess that retention time, paper strength. I can tell you from past experience, Wapma 1, when I go to pull that filter paper out of the funnel, it usually rips. And I can tell you all the Wapma 40s, 42s, they come out as a chunk. When we tried this with this particular soil, those cone filters, they held up. We tended to tear the ones when we tried to use depleted filter papers. It's a thinner type material. Recommendation, I say you buy your filter paper a lot and immediately throw it through testing to see what the contaminants are. And finally, is failure on this can result in costly errors, re-extraction of samples, which slows down throughput, and it increases the potential of you having QC failures and have to run a whole batch over. So, want to take a moment to celebrate something? Last Friday, guys, it was only 5 days ago. My 3 sons, he's not in the picture, he's taking the picture. The third son. These are my sons, Colin and Matthew. We climbed. Sorry, I choked up with this. We climbed Mount Biggerstaff in Colorado. It's a 14,000 8-foot peak. We did that 8 miles, 6 hours, almost 3,000 foot elevation. And I say this because this was one of my goals. My boys. So sorry, guys. I get choked up over this because I didn't think I could do it. Anyway, questions. Focus on the filter paper. Go ahead, Justin.
Do you think that the malic-free soil interaction, liver-free extract, still happen? People feel different while they're in contact?
You know, that would have been a great study to throw in.
That case for filter speed after impact.
I will say this. I think the malic-free is pretty stable after 5 minutes. Don't know that. But the reason I say that, I've looked at this on Olson and Bray, and it doesn't seem to change. But I'm sure there are those exceptional soils that it does happen. Yeah. And the last thing is this. would have been really nice to collect that first 5 mils and the next 5 mils and the next 5 mils to see if the number changes, because that would tell you, right?
That was actually a question, because I know sometimes you're in a rush, don't let the whole filtration come through. So regardless of filter paper, you feel like there's probably a risk if you don't let all the solution go through the filter.
I think, first of all, think about it. If you're doing 20 mils, and you're gonna IC tube of 15, right, or 20. If you sort of change that very much, you're gonna run a sample not and that kind of spray change.
I know I had a soil fertility professor that always told me, think about when you're brewing coffee. It's the initial coffee thicker or less, as it goes through. So I know there's one.
Go ahead.
What is your opinion about land arrest? If there are sometimes those land arrests, are we still acting?
Okay, I don't have a problem if you're 10 times, 100 times in concentration, like, okay, let's just hypothetical, we're doing nitrate TCl extract. And if your nitrate samples are 30, 40, 100 part per million, and you got a half a part per million, okay, I'm okay with it. But now think about if you're in that 5 part per million area, and what your MDL is anyway, yeah, I have a problem with it. That's why the lab in Canada spent a fortune washing filter, which was such a fun.
Also, sometimes the filter paper is just not like, when do you do the blank, right? Like it may not be uniform across the whole lot. So
Yeah.
the contamination is in, like a lot of times you get a box and there's multiple packaging within that silo of 100 or 200. So where do you do the blank? Trusting a blank in that situation.
I was quite surprised that the conical papers were all seemed to be cleaner. There were two different manufacturers, okay? One of the conical papers came out of a guy that does it in Texas and no longer doing that. The other one was out of another manufacturer. I was surprised that they were very consistent. Now, I got a random sample, I'm sure, out of those 4 labs that I asked for. So I think that's representative. But as you pointed out, the different lots, who knows with I picked a lot that came in March and then they opened the box 6 months later, it's sending.
What about
contamination?
how many labs do you know of are still hand-folded?
I don't know very many labs are doing it, but I know a particular manufacturer in the Midwest is holding photo papers and so on.
But they're not hand-folded.
I don't know that. Go ahead.
So up here, it's like, the person running the
If you're, okay. Okay. So if you're running things that are kind of a water soluble assay, like saturated case and these kinds of things with the water tap. If you're doing things like for plant digestion, I think you need to do a digestion, treat them as a digestion blank. For malic 3, as far as I'm concerned, if you run a malic 3 extraction on them and don't find anything, or if you do find something, that should be what you should do. Whatever is, treat them as a blank in your procedure.
Or you do both, right? So especially with the mailer 3, you may be getting contamination with the mailer.
Well, that's a separate issue.
Yeah, so but to figure out where it's coming from,
Yeah.
you may have to do multiple steps.
If you've got, listen, if you run mailing 3 and you've got a good DI water source and you're doing your batches and you've got a good cleanup procedure and SOP for the water making the mailing 3, I don't think that should be the issue. If you're getting contamination, go forward then and see what the filter paper is. Or the quality of your washing system, the washing out extraction. So, okay?
Any other questions for Bob?